Hello viewers, welcome to another video of Smart Pathshala. So in this video, we'll solve some problems of miscellaneous exercise of the determinant of the NCERT books. Okay, so let's start without any delay, right? So this is the problem number 1, where we have to prove that this determinant, that is the given determinant, is actually independent of x. Okay, let's go to the solution. So in the solution has been done in a very simple manner. Okay, so we have the determinant as delta is equal to determinant of x sin theta cos theta and minus sin theta minus x 1 and cos theta 1x. Okay, so and here we actually expand this equation. Okay, we expand this determinant, sorry, not equation, but it's an determinant. So we expand it along the row number 1. Along the row number 1, we expand it so that we can get x into, see, this x into x square minus 1. Okay, so in this way, if we do this, we'll get x cube minus x plus x sine square x plus sin theta cos theta minus sin theta cos theta plus x cos square theta, right? So let's not go into the mathematical jugglery over here. So we know the process so that we can get x cube, which is actually independent of theta. The result does not consist of theta, which actually indicates that it does not contain theta, and this is independent of theta, hence it's proved. Okay, now let's solve the question number 2. Okay, so it says without expanding the determinant, this one, we have to prove that these two determinants are actually equal to each other, right? Let's say the LHS to be a square, bc, b square, ca, c square and ab, right? Okay, here say we are multiplying on the first column, sorry, on the first row with a, and on the second row with b, third row with c. What we'll get is a square, a cube, and obviously abc. Similarly, we'll get b square, b cube and abc as well. Similarly, we'll get c square, c cube and abc again, right? Okay, now take this abc out of this column number 1. Okay, so what you get is abc by abc, and here we'll get a square, b square, c square and a cube, b cube, c cube and 1 1 1, right? Okay, so that is quite similar to the desired equation. Only the problem is that the 1 1 1 column is on the column 1 and the square one is on the here side. Okay, so if we exchange these two columns, the meaning, that is the meaning of this equation, actually remains unchanged, right? So the meaning of this determinant actually remains unchanged. So that is actually RHS, and hence we have proved the given problem. So this is a simple solution, that is we have done is without expanding, and we have proved that the given this equation will be equal to this one. I hope you have understand the question number 2, and in this process let us solve the question number 3. In the question number 3, it says that we have to evaluate this equation, right? Now we can apply different types of determinant processes over here, but we will not delay our time, we will not waste our time by applying the properties, because we can expand it over here, that is column number 1. Column number 3. Why column number 3? Because we have a 0 over here and we have to do less calculation, right? So say we have minus sine alpha, and then you have this multiplied and then this multiplied, so we have minus sine square beta sine alpha minus sine alpha cos square beta, right? So 0 in the second element is 0, so we don't have to calculate it because that will be actually 0, right? So again we have to calculate cos alpha. For this element we will calculate this one, right? So we'll have cos alpha cos square beta minus minus plus cos alpha and sine square beta, right? So here take this minus out of this bracket so that we can get sine alpha, and also take this sine alpha as common, right? So we'll get sine square alpha, and here you will get sine square beta plus cos square beta, plus here just take this cos alpha out of that bracket, you will get cos square alpha and cos square beta plus sine square beta. Now similarly, this term is actually 1 and this term is actually 1, so you are having sine square alpha plus cos square alpha, and that is actually 1. Hence we have calculated this problem, right? This is the problem number 3. Let's proceed to the question number 4. So this question number 4 is a bit tricky because here the value of this determinant is given, while you have to show that either a plus b plus c will be 0 or a equal to b equal to c, right? Okay, now delta is equal to 0. So this delta is actually b plus c and c plus a plus b, c plus a plus b, b plus c, a plus b, b plus c, c plus a, right? Okay, now what you need to do is you just add all the columns, right? Let us change this c1 as c1 plus c2 plus c3, right? So when you add, what you actually get is 2 into a plus b plus c, and again over here 2 into a plus b plus c, and 2 into a plus b plus c, and c plus a and a plus b over here, a plus b and b plus c, b plus c and c plus a again over here. Now take this 2 into a plus b plus c common, right? So when you take this a plus b plus c out of that box, bingo, we have the solution. Whenever and wherever in any determinant problems, if you are having this column having all the elements as 1, then what you need to do is to keep one row as constant and just subtract that constant row from the other consecutive rows. So take this 2 into a plus b plus c and keep this 1 c plus a and a plus b as constant. So you just do row 2 change to r2 minus r1 and r3 change to r3 minus r1, right? So you just subtract 1 minus 1, it will yield 0, and this one it will yield b minus c, and this one r2 minus r1 it will yield c minus a, and when you do r3 minus r1 it will get you 0, and again it will get you b minus a and c minus b. Okay, now right here you just have to, okay, I think we have done a little bit of mistake. This one will be 0, right? Yeah, so this one will be implies 0 implies, this one will be 0 implies, and here we need to write 0 implies 2 into a plus b plus c, and hence when you expand it along the column 1, what you will get is b minus c into, you know, c minus b minus c minus a into b minus a, right? So that is actually equals to 0 again. So what you are having, sorry, so what you are having is a plus b plus c, and over here what you are having is, you know, b minus c whole square, and over a minus over here, and again here you have bc minus ca minus ab plus a square, so that is 0. Now from here, you know, we can easily write that either a plus b plus, you know, c equal to 0, or from this equation we can directly write actually that b minus c whole square equal to minus bc plus ca and plus AB minus A square. So what you are having over here is B square plus C square minus 2BC is equal to minus BC plus CA plus AB minus A square. So when you expand, okay, when we expand this one, no, this one, so what you have here is this one, right? A square plus B square plus C square minus BC minus CA and minus AB, so that is equal to 0. So what you have is A minus B whole square plus B minus C whole square plus C minus A whole square is equal to 0. Now this is only possible when these perfect squares are actually individually 0. So when A minus B will be 0, then obviously A will be is equals to B. Similarly, B will be is equals to C and C will be is equals to A. Hence we have A equal to B equal to C, right? So this is the required solution. Okay, so this one and this one, these two are the required solution. Again, so we have to solve this equation. Suppose what we need to do here is to add this determinant. Okay, you just add row number 1 is equal to R1 plus R2 and plus R3. So what you will get is 3x plus A, again over here 3x plus A, and over here 3x plus A equal to 0, and you have x plus A, x and x plus A, right? Now take that 3x plus A common, right? Okay, take this 3x plus A common, then what you will have is 1 1 1 x plus A, x and x and x plus A equal to 0. So now, as I have said, that this 1 1 1 is actually a jackpot, right? So what you need to do is to take one of the column as constant and then subtract that constant from the other one. So what you are having is 3x plus A. Okay, so you are having 1 x, right? Okay, then what you need to do is to subtract the column number 2 from column number 1. Similarly, column number 3 from column number 1 again. So what you need to do is you will get 0, and over here A 0 again, and here is 0 0 and A over here, right? Now this is quite clear that what we will get over here is 3x plus A, and after expanding this determinant along the row, what you will get is only A square, right? So take this A square in that right hand side. What I will achieve is 3x plus A will be equal to 0. Therefore what you are getting as x is equal to minus of A by 3, right? So this is the required solution of the given problem. I hope you enjoyed our small lecture. We have solved first 5 problems of the miscellaneous exercise of the NCERT book. So try to follow up with us for the other lectures so that you can learn with us and grow with us. See you on the next video and with the next problems.